All right, everybody, we have a new unit. We had the mole unit and the balancing unit, and when you combine those, you get stoichiometry. It's amazing. Yay! I love it. Make sure you know how to say it, stoichiometry. A lot of times I'll just say stoic. So here's some sample problems, and I'm using the Pharaoh's worksheet as a guide, but I'm going to use a sample problem that's different than what's on Pharaoh's in order to show you how to do it with something different. All right, so my sample problem is solid iron mixing with oxygen gas, and you get rust, iron 2 oxide, or iron 3 oxide. So here's our sample problem. How many moles of Fe2O3, or rust, will be formed when starting with 3.5 moles of oxygen? So this is just like the mole unit. You have to do the same steps, but now we have an equation. That equation will help us go from moles of one substance to moles of another substance. So first, we need to balance that equation. So I quickly did that. Each of those represents how many moles you will need to balance, kind of like the s'mores lab, but now with actual substances. All right, so first, mark the text. Underline in what you're given and circle where we need to go. So I underlined 3.5 moles of oxygen, and I circled that we need moles of Fe2O3. Then whatever we underline starts our setup. So 3.5 moles of oxygen gas. If I want to get rid of those moles of oxygen, I'm going to put moles of oxygen on the bottom. So there's 3 moles of oxygen per every 2 moles of rust. I found that on the balanced equation. So I just put that in my table. I make sure my units cancel out, and I solve. So I found out there's 2.3 moles of rust. Now, this is equivalent to number 1 on every page on Pharaoh's. So let's see if you can do the first page right now. It's your turn. As a quick joke, why does Snoop Dogg carry an umbrella? Faux drizzle. Dun, 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 dun. You're welcome. All right, second question. How many grams of Fe2O3 will be produced if I have 3 moles of iron? So I'm starting with 3 moles of iron, and now I'm trying to get to grams of rust. All right, so just like before, I mark my text. I underline and I circle. 3 moles of iron, grams. So I'm going to start with those 3 moles of iron. Now, last time we were able to get rid of those moles of iron by looking at, or moles of anything, by looking at the balanced equation. So I can get rid of moles of iron by looking at the equality between iron and rust. So looking at the balanced equation, there are 4 moles of Fe per every 2 moles of Fe2O3. So that's why I put that in my equation. Now, the top right is now rust, and it's moles of rust. I need to get to grams. That's why now it is very, very important that you have all your units. So now I see that's moles of rust. I have to get to grams, so I need to cancel that out. So per every 1 mole of rust, I can look up the molar mass. The molar mass of Fe2O3 is 160. I just added them all together. So that's why my moles of iron's canceled. Now my moles of rust cancel, and I can get to grams. So I put in the parentheses, I put it all in my calculator, and I get that it's 240 grams of rust. And that's how I get my final answer. Okay, so now it's your turn. New joke. How did the hipster burn his tongue? He drank his coffee before it was cool. All right, new question. So now this one's going to be kind of like number 3, where we're now going to start with how many moles of oxygen gas must be used if I produce 226 grams of rust. So I already know after the fact, I have 226 grams of rust. So I want to know how much oxygen it took to make that much rust in moles. So underline, circle, start with what I underline. Get rid of those grams with how much rust weighs. So rust weighs 160 grams per every 1 mole. Notice I can't use the molar ratio yet because it has to be equality. The molar mass is only per 1 mole of the substance, not for multiple, it's only for 1, okay? So now to get rid of the moles of rust and get to moles of oxygen, I will have to take and use that molar ratio. This is the magic step. This is how you go from one thing to another and have everything cancel out. This is the reason why it's called stoichiometry. All right, so I made sure everything cancels out. I'm going to put it all in my calculator. And my answer is 2.1 moles of oxygen gas. Please make sure while I'm doing these that you're also putting these in your calculator to make sure you are calculating these correctly. All right, so guess what? It's that time again to do number 3 on your worksheet. It's your turn. And here's my story. A blind man walks into a bar and a table and a chair and you get the point. All right, next question. This lines up with question number 4. So how many grams of iron are needed to produce 208 grams of rust? So I mark my text. I underline what's given, circle where I need to go. So whatever I underline, that's what starts every time. So 208 grams of rust, Fe2O3. I want to get rid of grams of Fe2O3, so I'm going to use the molar mass of Fe2O3 to get rid of it. If I'm using that molar mass, 1 mole always goes on top. So there's 160 grams per every 1 mole. Then I use that magic step, that mole to mole ratio, to get rid of the moles of rust to get to moles of iron. And I look at my balanced equation and it's a 2-to-4 ratio. So now I'm down to moles of iron, but I circled grams of iron. So I'm going to have to take this one step further. I have to get rid of the moles of iron and get to grams. Well, that's the molar mass. So per every 1 mole of iron, the mass of it is about 56 grams. So I now make sure everything's canceled. And I put in my parentheses, put it all in the calculator, and ta-da! It's 146 grams of iron. Notice, I circled what I circled in the problem. So whatever you circle in the problem should be the top right every time. Then you know you did it correctly after you cancel out all your units, okay? That will be another check to help you out. All right, make sure you're able to do this as well. And now, guess what? It's your turn to do it. La, 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 la. All right, here's another joke. I used to think the brain was the most important organ. Then I thought, look what's telling me that. So number 5. Sorry, I know these are lovely jokes. If I have 207 grams of iron in a tank filled with 168 grams of oxygen gas, how much rust will be formed? So, if you just leave a piece of iron somewhere and you want to know how much rust will just form on top of it. So let's find out. I underline and circle. Now, the thing is, I have 2 numbers given. So I'm underlining 2 things. Well, if I'm underlining 2 separate things, that means I'm going to have 2 separate setups. That's right. I will have to have 2 setups in order to solve this problem. Because one amount might give me one answer and another will give me another. It's kind of like in the s'mores lab that if I have 36 pieces of chocolate and 46 graham crackers and only 15 marshmallows, how many s'mores can I really make? It's the least amount based on what's given. So we're going to have to find that out because it's not like s'mores and you could just look at it and go, well, duh. So let's start with that oxygen gas. I have 168 grams of oxygen gas. To get rid of grams of oxygen, I need to use the molar mass of oxygen and get to moles. And then I gotta get rid of those moles of oxygen to get to moles of rust because I gotta convert there. So there are 3 moles of oxygen gas per every 2 moles of rust, and I put that in. Then I need to get to grams. So I put that in, and there we go. Got rid of my moles, got to grams. I'm going to make sure all my units cancel, which they do. Put in my parentheses and solve. I get 560 grams of rust. So that's how much that much oxygen can produce of rust if it was only dependent on the oxygen. But I also have 27 grams of iron. So I'm just going to put my answer to save space underneath my oxygen over here just to say that's what caused that many grams of iron 2 oxide. I should have labeled it with iron 2 oxide as well, but I didn't. All right, so that's my first setup. My second setup will be with that 27 grams of iron. And same thing, get rid of the molar mass with the grams of iron with the molar mass of iron to 1 mole of iron. So now I'm to moles of iron. I'm like, I don't want moles of iron. I'm going to get rid of those with the molar ratio so I can get to rust. That's how I switch. It's the magic step. And that's the only time I'm looking at my balanced equation, so 4-2. Then I get rid of the moles of iron 2 oxide or iron 3 oxide, and I go to the molar mass, just like before. Cancel out my units, put in my parentheses, put it all in my calculator, and I get there's 39 grams of iron. If that's the case, then, or 39 grams of iron 3 oxide, my mistake. So the iron produced way less than the oxygen would. So if I have both at the same time, that means the iron's going to run out. So by that time. So I can only produce 39 grams of iron 3 oxide. So my limiting reactant or limiting reagent is going to be iron because it's going to run out no matter how much oxygen gas I have. Okay, so iron is my limiting reactant. Fun fact for this one, that dot is called a tittle. You ever know that? That the dot, an I, or a J is called a tittle. Fun fact. Just like Nike, just do it. The next problem. All right, question number 6. A 205 gram sample of iron has an actual yield of 246 grams of rust. Find the percent yield. Okay, so this one you have to read a little bit more carefully. So I do start with 205 gram sample of rust, but then it says something about a percent yield and an actual yield. So that's when you need to know this equation. Percent yield is the actual result divided by the theoretical times 100. Let's go what that means, okay? I would put this in your notes though, all right, of what this means. So you know what a percent yield is. So theoretical is if everything went great and nothing from the outside came in, then that's how much you should get. The actual is if you did it in an experiment, because sometimes it's too wet, it's too hot, there are so many other factors that can come in. So that's why actual is just what you really got or what really happened. So in this question, when I said the actual yield is 246 grams of rust, that means I had 205 grams of iron, I put it somewhere, and then after it rusted all out, I scraped off all the rust and saw there was like 246 grams of rust. So I want to see what should have happened with 205 gram sample of iron. So I'm going to use my stoichiometry problem to figure out what the theoretical was. So I start with that 205 gram sample of iron. I switch from the iron of grams to moles. And then I need to still get to rust. So I got to get rid of the moles of iron to moles of rust using my molar ratio from the balanced equation. And then I go, oh wait, I need moles to grams because I need the mass. Okay, a lot of times you need masses if someone says how much, because you can't count moles, right? You can only measure in grams. So I cancel everything out, put it all in my calculator, and theoretically, I should have gotten 293 grams of rust when I actually got 246. So a percent yield tells us how much, did we actually get? Because this is important, because if you are actually trying to make something, you want as much of a percent as possible. Could you imagine if someone said, hey, you can synthesize your own gold after doing this days and days long process, and you can get a ton, but you didn't know all the errors and you did your percent yield and find out it's only 20%. Well, that's not worth it if you only get 20% of all that work. You want 100. I mean, time is money. So using that, we're going to do our actual divided by the theoretical times 100 to find our percent yield. So our actual is 246, and our theoretical is the one we just got. I didn't put grams on this. Good job, Waldron. Grams. Okay, that's why they cancel out. We can get a percentage. So I divide those two times by 100, and I get about 84%. That's pretty good. In reality, things are not 100%. It's hard to control everything, especially here in Texas where you got humidity and everything as a factor as well. So that's what I mean by percent yield. And there you go. And you know what? You want to hear a pizza joke? Never mind, it's too cheesy. So, yay! You got one page done. Now you should work. Good idea. Good idea, Miss Waldron. This lovely video was brought to you by Wally, known as Waldron. I hope you enjoyed.